Bismillahirrahmanirrahim. My name is Adel Shabana. I'm Assistant Professor of Cardiology in October 6 University, and this course is about connection and basics of ECG for the skill lab for second year students. So this part is about the physiological basics underlying the ECG. So let's revise with each other what's going on. So as we all know, the heart is formed of four main chambers: right atrium, right ventricle, left atrium, left ventricle, and there are valves in between right atrium and right ventricle. This is the tricuspid valve. Between the left atrium and left ventricle is the mitral valve, and then right ventricle opens into the pulmonary artery, and there is a pulmonary valve there, and the left ventricle opens into the aorta, and this is the aortic valve in between. ECG or EKG, this electrocardiogram is the tracing or graphic representation of the electrical activity of the heart. How we are doing this ECG? We are placing what is called electrodes. These electrodes we are putting on the skin of the patient, and we are detecting, the machine can detect the electrical current activity inside the heart occurring related to these electrodes. And these electrodes can detect the charges on the cell from outside, if it is negative charge or positive charge or what. In order for the heart muscle to contract, they have to be electrically stimulated, similar to any muscle in the body. And stimulation means depolarization. Depolarization means changing in the polarity of the cells between inside and outside. So the cell, what's happening? Some gates open, then sodium and other electrolytes gets inside the cell. The polarity of the cell changes between inside and outside, and this produces some kind of molecular changes leading to contraction of the cell. Later on, repolarization should occur, and the cell should return back to its original resting state in order to be depolarized again. Inside the heart, we have two types of cells. Some cells are specialized in producing and transferring the electrical impulse. So we call these electrical conduction cells. So they can produce the electrical activity. These are the pacemaker cells, and other cells carry the impulse very fast between the cells of the heart, and this is called the conduction system of the heart. So what we are concerned with for the ECG is these types of cells. The pacemaker cells, which are the cells which can produce impulses in its own. It does not need outside stimulation. And the conduction system, which transfers the impulse quickly inside the heart. So the pacemaker cells, they can generate impulses by making spontaneous depolarization over and over and over. And they can produce the impulse and transfer it to the other cells. Even without the conduction system of the heart, the cells of the myocardium have in between some connections in between. We call them gap junctions, making them they can transfer the impulse between different cells. I mean, when one cell is depolarized, it can depolarize the next one, and the next one, and the next one. So we have cell-to-cell depolarization which can occur in addition to the specific conduction system of the heart. The pacemaker of the heart is what we call SA node, sinus node, or sinoatrial node, which is a spot in the right atrium of the heart. So in a certain part in the right atrium of the heart, some cells are specialized and they are capable of doing spontaneous depolarization and produce the impulse which will be transmitted to all the heart. We call this the pacemaker of the heart. It is in the right atrium, outermost part of the right atrium. And then the impulse will depolarize the atria Okay, it will be depolarize the right atrium, the left atrium. Then the impulse will come to another spot of specialized cells called the AV node, atrioventricular node and bundle. AV node and bundle, or atrioventricular node and bundle. This AV node, we will talk about it later. It will keep the impulse for some time, and then the impulse will be transferred in this yellow, in this network of conducting system. It is called the left bundle branch and the right bundle branch. So obviously, left bundle branch will go for the left ventricle, right bundle branch will go for the right ventricle, transmitting the impulse very quick in order to allow contractions of the ventricles. So the sequence of events occurs as follows. SA node discharges the impulse. It stimulates both atria. Then the impulse comes to the AV node, stays for a few milliseconds. And why is that? To allow the atria to depolarize, to contract, evacuate their blood before the ventricle contracts. Because if there is no delay in the AV node, the impulse will go quickly to the ventricles, and both atria and ventricles will contract in the same time. So after this, some kind of pause, the impulse will go quickly in the left and right bundle to finish the depolarization of the ventricle. And of course, each part will, which is depolarized will be repolarized again. So as we said, the pacemaker of the heart, the main pacemaker or the dominant pacemaker, is the SA node. It has an intrinsic rate between 60 to 100 beats per minute. This is without stimulation. I mean, without nerve, sympathetic or parasympathetic or medication or anything. The SA node itself, without being connected to anything, it has an intrinsic rate of 60 to 100 per minute. But we have backup pacemaker, because if the SA node is not working, then some other area should work, which is the AV node. The AV node can act as backup pacemaker, but its intrinsic rate is less than the SA node. This is why the SA node is the dominant one. So if there is something happen in the SA node, the AV node will work as backup pacemaker, producing a rate between 40 to 60 per minute. Okay, what if SA node and the AV node both are not working? Then the parts in the conduction system in the ventricle, it will also can discharge and act as backup pacemaker. These areas are called Purkinje fibers, which is the terminal ends of the conducting system, and they can also work as pacemakers, but they have very slow intrinsic rate and they are very unstable. But they can save the patient for some time until some action can happen. Because if this is not working, the heart will stop. Okay, how the sequence of events is represented in the ECG. SA node and atrial depolarization will appear as a P wave. So the first wave in the ECG is called the P wave, representing atrial depolarization of both atria, of course. Then, when the impulse reaches the AV node and the bundle, we call it bundle of His, or AV node and AV bundle, there is some delay. So after the P wave is finished, there is some segment here. We call it PR segment, which represents the delay that happened in the AV node and the bundle. And then the impulse will go very quick in both ventricles, in the left bundle and right bundle branches, producing another wave, big wave, called QRS complex. So QRS complex represents ventricular depolarization. So P wave is atrial depolarization, QRS is ventricular depolarization. And then the ventricle will repolarize. After some time, the ventricle become repolarized, producing the T wave. So the question here is, where is atrial repolarization? Actually, atrial repolarization occurs, but because it occurs during ventricular depolarization, it will not show in the surface ECG. So what we have now is P wave representing atrial depolarization, QRS complex representing ventricular depolarization, T wave representing ventricular repolarization. We also have this segment is called the PR segment, which represents the delay in the PR in the AV node. but we have also what is called the PR interval. So there is PR segment and PR interval. PR segment is this small area, but PR interval includes the P wave in it. So between includes the P wave and the PR segment. So P wave and the PR segment are called together PR interval. And here between the QRS and the T wave there is ST segment. So ST segment is the period after the polarization finish and before repolarization start of the ventricles, of course. So see you in the next lectures, inshallah. Thank you.